big B make black pigment, and then organisms that have at least one wild-type copy of the agouti gene make tan or yellow bands on the hairs. In animal that is mutated for both copies of B, the hairs will completely lack pigment. And then it doesn't matter what agouti is. You will get no deposition of yellow or tan pigment on the hair. So we would say that in this situation, the gene B is epistatic to A because the genotype at B controls our ability to see the phenotype resulting from A. So epistatic relationships are not between alleles of a gene, but they're between different genes. And they are a way of describing a relationship where one locus controls our ability to see another locus. So one of the classic examples is people say baldness is epistatic to hair color. You know, it's kind of silly, but if you're completely bald, the genes that govern your hair color cannot be expressed. There's no way for them to be expressed. Okay. So that is epistasis.
I had more on it. So
Yeah.
when we were talking about like the UDI specifically, we talked about like the positive and negative feedback loop and the deletion of the gene. Is that what you're looking for on a molecular basis, or are you talking more about this, the relationship between genotypes and phenotypes? Because I was unclear on what you, because it says molecular basis.
Yes.
So I didn't know which part of that you were looking for.
Okay, so in this case, if the organism makes no black pigment, then if it makes no pigment at all, it cannot produce the downstream pigments, like the tan pigment. So this is essentially an upstream block in a pathway.
So when you're talking molecular, you're talking about how the genotypes cause them to interact versus and then we talked about the specific deletion of the genes and stuff.
Okay, I think here there isn't necessarily a deletion of the genes in this example.
I think he means for the agouti yellow one,
Yeah.
just
Yeah.
which,
Okay.
how specific
Shall we
you
go
want it to be.
on to the gain of function? Dominant phenotypes, okay.
Well, it's still because this is still the agouti pretty much, isn't it?
Well.
Because based on when we're talking about the yellow bands, it has to do with the agouti gene.
Yeah, yeah.
And
But here I'm just imagining a wild type agouti, not the agouti yellow, which is a gain of function.
okay.
Yeah, a dominant, misregulation dominant. Yeah.
Can I say that fruit one is also epistatic to blood types?
Yes. I knew there was another example in here, but I couldn't remember what it was. So, when we talked about blood type, there is a pathway that makes substance age.
Really quick before you move on to that, so for his
Yeah.
question, so when you're asking about the molecular basis, you would want us just to, when it says explain it how, you said B is epistatic to A?
Yes.
That's what you would want us how to explain it, right?
I would want you to say that B is epistatic to A, and in a little b animal, no pigment is made.
Okay,
So the agouti, which deposits that yellow or beige pigment, it cannot be expressed.
okay,
Okay.
thank you.
So
Thank
it lacks a necessary precursor.
Okay.
Okay, so this blood type